Hello everyone, we are back on my YouTube channel Best Achiever. So we are continuing our digital electronic series. In that basically we have already completed with the combinationals part. We are now basically dealing with the sequential circuit. So I already introduced the flip-flops. What is flip-flops? Now basically we are dealing with the main flip-flops, that is SR flip-flops. There are many flip-flops. We are going to study like many means 4 flip-flops we are doing. Okay, so let's start with the first flip-flop, that is SR flip-flop. Okay, S and J base, S and R basically set and reset flip-flop is there. So first I will basically start with the circuit diagrams. I will draw basically the circuit diagram of it, and after that basically we'll see the truth table of it. So let's begin. Circuit diagram. I am drawing this SR flip-flop using NAND gate. You can even draw this circuit diagram by using NOR gate. So this circuit basically comprises of latch also. We are giving control input to this latch, you will get the flip-flop. So I already gave you the idea of latch in previous class. So I must know that you have watched this my video previous one, so you basically get to know that this part is called latch. This part is called as latch, SR latch. This part is called as SR latch. Okay, and I am applying the control input, so that's why you are getting the flip-flop. Okay, in exam sometime this will provide you like this. Okay, in exam they will give you like this. Okay, understood? So this is your part, circuit diagram, and this is your block part. Okay, this thing you need to remember because this is really important. Okay, by using this circuit only, you will get to know the truth table. Okay, now basically we'll draw the truth table, but before this basically I will just conclude about little bit. I will give you the knowledge of latch in this part. Okay, so in this basically like S dash, R dash and Qn. Okay, 0 0 0 1 0. Okay, I am giving the output of this part. Okay, so how this is related, and then after that basically this part how it get the output. Clear? So this which part I am getting, so any of the input is 0, it will give you high only. Okay, because any of the input is given to the NAND which is low. Okay, so it will directly give you the high. Okay, so both the input are 0, both will be high, means 1. Now this part is basically 0, so this will give you what? Any of the input is 0 to NAND gate, it will give you high. High means this. Now this one will come here, 1 and 1 will give you 0. You have to remember the NAND gate truth table and NOR gate truth table because this is directly important. Okay, even I taught this NAND and NOR or all logic gates in my previous classes, so you can watch it. Okay, now whenever input is 0, just pick that part. So this is R dash, so input is 0, give you 1, so 1 into 1, this will give you 0. Okay, now both are input 1, both 1 means 1, so means basically it will remain in that state only. Understood? So this is clear. What we have drawn, what we have picked out basically S dash and S bar. Whenever input are S and R dash, it will give you this part. So this is the basically what basically SR latch output and SR latch truth table. Clear? So now what we have to do basically, we have to find the relation between this. So S is what? Now basically we are finding the input. Input is this and output is this. Now basically, so we have drawn, before we have drawn the basically S dash and R dash are the input and this is the output. Okay, now we are basically dealing with the basically dealing with the what flip-flops. The latch part is done. Now the truth table of flip-flop will be done. Okay, now we are finding the relation of S dash. S dash is what? S into clock bar. So by De Morgan's law, S bar plus clock bar. R dash is what? R bar plus clock bar. This is by what? De Morgan's law. Getting me? Okay, now we will find the basically final output, final truth table of what? Truth table of SR flip flop. Okay, I taught you, because this I taught you latch output, because it is really important that if you know the latch, then you basically will come to know about the flip flops, because latch is basic memory element which stores the data. Okay, so for that purpose, that's why you have to remember the latch part, and then basically you will go by step flip flops counter. Okay, so now we'll find the basically final output of this. So S and R 0 0 1 1 0 1 0 1, because S and R is the basic input now. S dash and R dash is not the input. S dash and R the input of the intermediate part. We have to find the input. This is the user input. Okay, so you are finding the input, that part. Understood? Now basically when S, just see over here, when S and R equal to 0, when S and R equal to 0, clock will always remain high. Okay, so always high means high ka complement is what? 1 ka complement is 0, so 0 plus anything is that number only. Okay, so S bar and R bar, so both our input is 0, means 0 ka complement 1, so 1 1 will come here. 1 1 means whenever the input are 1, it will provide you what? This part. Okay, that's why I have drawn this table, so this will remain there. Okay, so again now S is equals to 0, S is equals to 0 and R equal to 1, so 0 ka complement 1, 1 ka complement 0, so 0 1 0 1 0, truth table is 1 0 means it will give you 0 1. Understood? Same again, repeat 1, when S is equals to 1, this is equals to 0, so complement 0 1, 0 1 means what? 0 1 means this, so means output is what? 1 0. Clear? Now when both the input are 1, 1 1 means 0 0, 1 ka complement 0, 1 ka complement 0, so 0 0 means what? 0 0 means. Okay, so now this is what this state is called as, this state is called as memory state. Okay, or holding state, valid state. Okay, now this state is called as reset state, this called as set state, and this called as not used, and you can say invalid state. Understood? So this is really important what we have studied. Basically in that what I taught you, the SR flip-flop circuit diagram is important. This is important. This is the latch part, and this after applying the clock to the input. Okay, after applying to the previously I applied, means okay, here I applied, so basically the latch become flip-flops. Okay, the control phenomena is applied to this circuits to latch, so you will get the flip-flops. And I took this much circuit here, and basically I drawn the truth table of latch, and after that I conclude the what is S bar and R bar. Using that only relation I draw the truth table of SR, because the main input is what? S and R. S and R are the input now, so S dash and R dash is the intermediate input, so that's why I have one drawn. I split this circuits into two parts, and I have concluded the truth table. So this is really important. After that, in the next class, I will write the basically characteristics equation, characteristic table, excitation table, and many things are there. We'll go one by one and we'll complete this SR flip-flops. So till then, thank you so much. We'll meet in the next class.